Welcome to our second video on ratios in algebra. I want to continue from where we left off in the last video, which was using our intuitive sense of ratios and connecting it to an algebraic expression. And what I mean is we're going to look at a ratio and we're going to ask a question about the ratio, solve it, and then think how could that be solved with an equation. And hopefully we'll start to gain a little bit of sense about what this is happening, start to understand the logic here of how ratios and algebra connect. So what's this problem going to be about? Well, let's just make it up. Let's say we have a computer lab. So here's my room. It's a lab full of computers. They're running perfectly. Everything's going great. And there's 3 different operating systems in this room. So let's say we have the 3 operating systems. We have OS X, Windows, right, and Linux. And we know that in the room there are a total of, right, let's say, I don't know, 42 computers. And I tell you that, okay, out of those computers, here's the ratio of that relates to these 3 operating systems, OS X, Windows, and Linux. And let's just make that up too. The ratio could be, let's say, 2 to 5, right, to 7. And let's say that 2 represents the number of OS X, 5 represents Windows, and 7 represents Linux. Not trying to play favorites here, but it would be nice if Linux is being used that much in a lab, right? It's nice to see that kind of an operating system being used. But anyway, so these are our 3 operating systems. And the question is, well, how many of each computer are there that are running these operating systems in this lab? So how do we do that? Well, again, this is a part-to-part, right? This means for every 2 operating systems that are running OS X, there are 5 running Windows, and there are also 7 running Linux. So this is a part-to-part. And that means that we can add these 3 up, right? 2 plus 5 plus 7, and we get 14, right? And that means for, let's say, every 14 computers, there are 2 computers running OS X, 5 running Windows, and 7 running Linux. And that's 14 altogether. So the basic sense you have to get with ratios is that your goal is to figure out, well, how many times do groups of 14 fit into the total number of computers in the room, all 42? Because that will help us figure out the number of each computer that are running these operating systems. So the key here, of course, is division. 42, the total number, divided by 14, will tell me how many groups I have of this ratio, right? How many groups of computers? Because this group right here, if I just add the ratio up, I only get 14 computers. There are a bunch left in the room. So how many times does that group of 14 fit into 42? Well, 14 times 3 is 42. So 42 divided by 14 is 3. And that means, of course, that there are 3 groups of the 2 to 5 to 7 ratio. Ratio. And to figure out then in total what number of OS X, Windows, and Linux operating systems are in this lab, we take 3 groups of this ratio, right? In other words, we take 3 2s, 3 5s, and 3 7s. So multiply everything by 3, right? Because that's the number of groups. So we can think of this 2 times 3 and get 6. 5 times 3, we get 15. 7 times 3, we get 21. Add these 3 up to check your reasoning, right? I get 6 plus 15 plus 21. Well, 6 and 15 is 21 plus 21 is 42. So in this way, we're able to figure out how many of each computer there are in the room. But again, this is an algebra playlist, right? All about algebra. How do we connect this logic to variables and equations? Well, again, the key is the number of groups, right, of the ratio that you have that fit into the total. So the way I think about it is, I have 2 and 5 and 7. And I know that I'm going to scale up each part of this ratio by the same amount because I don't want to change the ratio. So that means I'm going to have some number of groups running OSX and the same number of groups, right, of 5 computers running Windows and the same number of computers or groups of computers running Linux, because we have to multiply each part by the same number. So our goal with that algebra is to find that missing number, right? How many groups are there? So if we add up these 3 groups, because we're finding the total here, right, we know that it has to eventually equal 42. And now if we solve this equation, we'll actually find the number of groups needed, because 2 and 5x and 7x, that's just 14x. And 14x is going to equal, right? In other words, 14 is the total number of parts times some number of groups will give me 42 in total. So if I solve for x here, I divide both sides by 14, right? 14's cancel out, and x equals 42 divided by 14, which, as we already showed, is 3. So by setting up this equation, we get x equals 3, and that's the number of groups we need of this ratio to fit into the total number of computers in the room. And you might not, this might not be working out for you in terms of the way I set it up here, so you might want to start by combining the 3 parts and saying, okay, I have 14, right, in total in this ratio. Add up the parts, that's 2 and 5 and 7 out of a total of 14. So I know 14 times something has to equal 42, because this ratio has to fit into the total number of computers in the room. So that might bring you directly to this step right here, which was 14, if I just rewrite it here, times some number of groups equals 42. And if you solve that equation, you're solving for x, and you'll get 3 groups, and you're done. Now what's interesting is, when I talked through this right here, all these steps about dividing, here you see it, 42 divided by 14 is 3. And to solve for x here, you'll do the same thing. You'll end up doing 42 divided by 14. You'll get 3. I just want to point that out because this intuitive reasoning here is this algebraic reasoning as well. They might look different, but they are the same thing. And that, getting that sense might really help us on our way in the next couple of videos when we look at some tougher problems. Alright, thanks.